Okay, so for statistics, we're going to jump into 4.4, conditional probability and independence. Conditional probability is written out as probability of A given B occurs. It is notated by that solid straight line right there, okay? That is how the given value is notated with a solid line right there, okay? So it's read as probability of A given B occurs. So the formula for probability of A given B occurs is equal to the probability of both occurring, top, so the probability in this case of A and B occurring, divided by the probability of the given occurs. So in this case, the probability of B. So again, as I just said, the probability of A and B divided by the probability of B. Independent, knowing outcome of one doesn't change the probability of another, or of the other, I should say. So to determine if it's independent or dependent, if the probability of A given B equals the probability of A given the complement of B, then it's independent, because one didn't change the outcome of the other, okay? Or change the probability, I should say, of the other. However, if the probability of A given B is not equal to the probability of A given the complement of B, then they're dependent, okay? They're dependent upon each other. Somehow, some form, those numbers react to one another. So we're going to go over a couple examples here and see how this plays out. Okay, so 4.4, do you prefer English or math? So definition, two events are independent if knowing whether or not one event has occurred does not change the probability that the other event will occur. Are the events female and prefers English independent? So I want us to collect data to fill in the following two-way table and Venn diagram. Well, I'm going to use data that I've had from previous class here, and we'll go about writing it out like that. So in this setup, for females who preferred English, I had 10. For males who preferred English, I had 6. For the females that liked math, I had 4. And for the males that liked math, I had 9. So again, we have this two-way table. The best thing to do is, before you start with anything, is get your totals around the sides here, okay? So we can go 10 plus 6 gives me 16. And 4 plus 9 gives me 13. And then we got 4 plus 10 gives me 14. And then we got 6 plus 9 gives me 15. So all together there, we should have 29. So 14 plus 15 gave me 29, and 16 plus 13 gave me 29. Now setting up this Venn diagram, a review from the lesson we had previously. So for the females that enjoyed English, preferred English here, right there in the middle, right? So females that preferred English right here at 10. So we know we should get 10 right in the middle. Now, females that did not prefer English, so they went after math, but they're still in the female category. There was 4 of them. Now, those that did English, well, this vertical column here, we got 10 that did English and were female. Well, the ones that were not female enjoyed English were 6 of them, were the males. And then for the category of not female and not English, so male and math, right in this bottom corner right here, we need to get 9. Again, you can simply think of this as just not English. And you can simply think of these as not female, okay? Because the main part of this problem we're talking about is we want to know females prefers English. We want to find out if it's independent. But if anything, for right now, we got the table and the Venn diagram set up. Okay, so now let's do a little review here on probabilities. So, probability of being female. Well, the probability of being female, we're going to look at the total in the females. So if we go across this row here, we got total being females. So we got 14. So there's 14, and how many is that out of? What's our total overall? 29. Okay, so now the probability of no female. So we're looking at the males, right? So we should have 15. If we go across the row here, we got 15. So 15 out of 29. The probability of just being English, let's look at that one. So just English, so we're going to look at this column here. So we got 16 over 29. And then for no English, so not English, no English, how you like to word it. Again, so we're talking about math in this setup. And we look at 13 over 29. Now, probability of female and English. So we want to know the probability of being female and English. Well, it's going to put us right there at that 10. 10 over 29. So the probability of female and no English. So probability of being female. So across the row, or the column, I'm sorry, the row here, right? And then no English, which is our math setup here, we should get 4 out of 29. Let's do this next one, the probability of English and not female. So we're looking at English, so this column here, and we'll look at the male, since that's not a female, so we should get 6 out of 29. And then no female, no English. Again, we said that was over here, none for all of them, right? We said that was our 9 value right here. So that should give us 9 out of 29. All right, so now we want us to find the probability of being a female or English. So probability of female or English. So our equation for this should give us probability of female plus the probability of English. And since it's an or statement, then we should have to subtract the probability of being female and English so that it's not counted twice. Female and English. Okay? Now we've got all these probabilities right here in front of us. We just did all the different probabilities to make this equation pretty easily solved. So the probability of being female, well, we got 14 over 29. Then we're going to add the probability of English. So the probability of English is 16 over 29. And then we're going to say the probability of being female and English. So female and English was this first one we did in the and statements. And that gave us 10 over 29. And then we just gotta add and subtract fractions. So we should get 14 plus 16 should give us 30. And 30 minus 10 should give us 20 over 29. Now the reason we had to subtract that again is because these are not mutually exclusive, okay? Female and English are not mutually exclusive. Because, again, let's look at this. Initially we said probability of being female. So we took the data right here to get the probability of being female. Alright, and then we took a probability of being English we wanted to add up. So we added up the probability of being English. So the number that we did twice there, the reason why we have to subtract the probability of being female and English is our 10. We did that twice when we added up those probabilities just by looking at probability of female plus probability of being English. That 10 value was put in there twice because 10 plus 6 gave us 16 and 10 plus 4 gave us 14. Well, we just need to add that 10 in there once. So simply all we had to do was take 6 plus 10 plus 4 and put that over 29. That's how we got 20 over 29. Okay? That's why that played out that way. So number 4 is asking, what is the probability that a student prefers English given that they are a female? Write as a percent. So we want to look at student prefers English given that they are a female. So we want probability they prefer English given they are a female. So again, when we did that, and our big idea is, let's do the probability of both, right? Both occur all over the probability of the given. The probability of the given was a female. So a given occurs. So for that, probability of both occurring. So probability of being female and English, right? Well, we already did that. That's this equation right here, or this answer right here for the probability, right? 10 over 29. So let's go ahead and write that, 10 over 29. And then of course the probability underneath there is probability given occurred. So the probability of being female. So just probability of being female, which we have right here. So probability of female is 14 over 29. Now, hopefully you guys remember that this is easily done for a fraction divided by a fraction. It's the same thing as multiplying it by the reciprocal. So we're going to take 10 over 29 times 29 over 14. So these 29s will go away and we're left with 10 over 14. Okay? And 10 over 14, if you put that in your handy dandy calculator or Desmos app or whatever calculator you're using, you should get 0.714 which is 71.4%. And 1%. You gotta read the problem, make sure you answer what it's asking for. So it's 71.4%. All right, so now let's go to number 5. It says, what is the probability that a student prefers English given that they are male? So again, we're preferring that English, so prefer English given they are male. So again, both occur divided by the probability of the given. So the probability of both occurring over the probability of the given. Well, being English and male. So in other words, English and not female, right? So English and not female. So we've got 6/29 all over the probability of male. So the probability, what do we have for that one? The probability of no female, which should be 15/29. So we should get 15/29. And with doing a simple little math there, you should get 6/15. And that should give you 0.4, which is same as saying 40%. All right, so the probability that a student prefers English given that they're male is 40%. That's the percentage it's looking for. So, are the events female and prefers English independent? And explain. Well, no. If we know a student is female, the probability that they prefer English changes. And it goes way up. So it's dependent. And we can check to see if that rule said, right? If the probability of A given B is equal to the probability of A given the complement of B. So you can check that rule. But hopefully you guys see here that in which case, as far as being female and prefers English, again, that highlighted value right there, if it changes, well then that changes everything for the English value probability and for the female probability. So if it's going to cross like this, and you can see that in a table, you should understand that it is not independent, okay? So again, no, if we know a student is female, the probability that they prefer English changes. It goes way up. So therefore, they are dependent. They're dependent upon each other, right? If a female and prefers English, they are dependent upon each other. Those numbers do change for the probability dependent upon one another. So, hopefully learned a little bit something today and going over 4.4 here for conditional probability and independence. And I'll see you next time.